How you gonna even talk about bones like that? I don't know. Bones is alive. We're gonna be talking about the basic structure of bone here in this one. All right, that's the plan. Let's get into it. So our bone. Let's draw ourselves a long bone. Got something like this. This will be like our femur. Boom. Well, this is already looking really good. Proud of myself. Oh, got a little fat there. It's hard to draw the mouse. You gotta cut me some slack. And then we gonna have our little... Whoop, no, that ain't it. Don't do me like that. What? Okay, I quit. Turns out I'm a bad professor. Alright. Okay, that is garbage, sorry. And it's like a mushroomy head. Dude, that is annoying. So if I click and hold on this, sometimes it'll start to select things. And that's what it's doing. Okay, that is bad. You know what? I'm just going to go with it. It doesn't have to be perfect. You get the idea. This would be like, you know, where your hip, your hip socket would be there. So this would be like your hip bone. You get what I'm going for here. Don't worry, I ain't going to be drawing out all these bones. We just need this long bone. All right, cool. All right, well, we got just a couple of little parts here on our bone. We got these parts up here and here. And we got this middle part right there. If you remember our kind of medical terminology, epiphysis. That means it's kind of the top part of your bone there. Epiphysis. 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 Epiphysis is how you say it. Epiphysis. But epi is kind of what I'm trying to enunciate. This, if you remember, means on top or above. So this is at the ends. We also call it the epiphysis if it's down at the bottom. Okay, and if you remember dia from diapedesis, that means across. So this is your diaphysis. It's the long part. It goes across the whole bone. Diaphysis. Okay, and this part here, the ends of your long bones, your epiphysis of your long bones contains your red marrow, which is where you make your blood. Convenient that it's called red marrow. Blooped. The blood. Where you make your blood, son. Now, where do you make your crypts? That's what I want to know. Just kidding. Just kidding. Okay, where you make your blood. And this part here, this would all have, and this is all in the middle here. This is where you store your yellow marrow. Yellow marrow. So this is like an energy storage system. It's just fat tissue. This is fat tissue. Delicious. This is why you put a bone in some soup and you boil that marrow out and it's delicious. Protein doesn't taste that good. The reason why meat tastes good is because it's got fat in it. All right, that's a little basics right there. And this boy, your bones got blood vessels in them, dude. Your bones got blood vessels all up in them. What just happened? So we got blood vessels. Blood vessels. And then kind of all along the outside, and we'll get to that next. And your bone actually looks something like this. I'm just going to do it here. Bro, this is too hard for me to do. Okay. So that is our compact bone. So it kind of goes around the perimeter. Compact bone goes all around the perimeter. And then up here we've got, I'm going to zoom way in and just kind of draw it like this. Like a crisscross smish mash. We got spongy bone. Looks pretty good. And this kind of runs all up at the ends of the bone and a little bit on the length, but not too far. And I'll show some pictures of this here in a minute, so you can get an idea if this is confusing to you. I think I may have actually shown a little bit of this. All right, so then we got that with the epiphysis, and this is our spongy bone. Spongy bone. All right. All right, well, let's do a little zoom in. Let's do a little zoom in here. I'm gonna do it like this, so you might want to switch over to a new page. Taking some hand-drawn notes here. We're gonna draw that little section in more detail. Actually, I'm gonna do it from the other side. We'll do it from that side over there. Okay. Let me actually do that just so it's accurate. Or I'll draw it reverse, that's fine. Okay. It doesn't matter. Okay, so on the outside we actually have a tissue, kind of layer of cells called the periosteum. Periosteum. So this is like a epithelial layer on the outside. Periosteum. Layer around bone. All right. Kind of surrounds the bone. It's a layer of cells. Layer of cells. Pretty nifty. Then we got our bone layers. The compact bone is very, very tight. Very, very tight. Compact together. Like so. Oh boy, I really jacked that up. I'll fix it. Ha! Got a nice little divot there. This bone needs some remodeling. But this can actually happen to your bones, and we'll talk about that. All right, and then we've got our spongy bone outside of this. And along the diaphysis, it's not a super lengthy amount of spongy bone. So something like that. Okay? Now, if you remember, I said that bones had blood vessels in them. So we're going to have blood vessels and actually run in through channels. So there's actually channels through this. And I'm going to zoom out just so I can make these channels kind of bigger. Well, let's say our blood vessels come in right there. And then maybe they'll go up here, down here, and they'll go out here to the periosteum. Like so. All right. And so we'll have our blood vessels coming in like so. And they'll run along the length of the periosteum as well. Okay, so we got blood vessels. Blood vessels. Blood vessels. We've got our compact bone and our spongy bone. Blood vessels. Okay. So we've got our spongy bone here. Spongy bone. And here we've got our compact bone. All right. Pretty nifty. All right. So now what we're going to do is right here, we're going to look down. We're going to look down at this thing and draw that over here. And you guys saw this in lab, actually. You looked at this. So what we've got is a series of rings. And they're filled in outside of that first one. Well, let's just draw it just like that, actually. So that would be the central canal, which is going to have our blood vessels in it. So we're going to have like our artery and our vein. I didn't draw the veins in this. Here I can do that. Just so this makes sense. Over there. So we'll also have our veins. We'll talk, if you don't know the difference between arteries and veins, it's okay. We're not there yet. We'll talk about that in the future. It's not super clear. This drawing is not super clear, but that's okay. All right, we got our blood vessels. We got our central canal. This is a top-down view of this central canal. So we've got this is a central, let me draw it actually in this color. It's a central canal. Okay. And then all along the kind of perimeter of this, we've got little structures that start to look like this. Kind of surround this central canal, and they kind of do it in these concentric rings, and it's pretty dang nifty. I love this about bone. It's so cool. Yeah, I think that's it. That's all we'll do. Okay. And these little things, these are where the osteocytes sit. So there'll be a little osteocyte in here. So there's going to be a little osteocyte chilling in here. Right? I'm not going to draw them all in, but there's going to be a little osteocyte chilling in here. Oops, that's not what I wanted. And there's going to be a little osteocyte chilling in here. So this little divot, this little hole that it sits in, it's called a lacuna. And if you remember this, I actually showed this over here. Let me go back over here. Yeah, look at this. This is really nifty. So you see our osteocytes sitting in this little divot, this little hole called the lacuna, and it puts out these little tentacles called, the tentacle's not called the canaliculi, but the little tunnel through the bone that the little tentacle goes through, the protrusion, is called a canaliculi. One of my favorite science words. Canaliculus is the singular, canaliculi is the plural. So I'm going to draw these canaliculis. I'll draw them in this lighter color. And what they do is they connect to this central canal. And they form this beautiful network. And these are essentially a giant diffusion network that allows the bone cells to be fed and to remove waste products. Because this is, again, remember, it connects to the cardiovascular system, the vasculature of your bodies. Very beautiful. Okay. I'm not going to draw it in, we'll just draw in half. Almost done. Not relaxing. It's like coloring or something like that. You know what? Let's just finish it. Let's seal the deal. Let's make a beautiful structure here. So this whole thing, this whole set of concentric kind of circles surrounding a central canal, it has a special name. And this whole structure is called an osteon. It's like a little subunit of the way your bone's built. So this whole thing is called an osteon. It's a beautiful little structure. Osteon. We got our central canal there. We got our blood vessels. That looks kind of trash. Blood vessels. We've got our canaliculi. I'm going to label a couple of them. Canaliculi. And again, these little canaliculi allow our osteocytes to put out these little protrusions between each other. Maybe that protrusion goes to there, maybe that one goes to there, maybe this one goes there, and this one goes here. And this allows them to pass nutrients and waste products between each other and the cardiovascular system. So this will go all the way down here. Boom. And allow them to kind of gather oxygen and sugar and all this stuff so that they can feed each other and remove their waste products. So the canaliculi allow osteocytes to connect with one another, forming a diffusion network. It's kind of like the internet or something like that. A diffusion network between them and the blood vessels in the central canal. Really freaking cool stuff right there. Like you now right now know more about bones than most people. Most people think bones are like this. Just a dead, boring thing that never changes. But your bones are, they themselves are just infested with cells, and cells are continually remodeling them and changing them. Pretty crazy. All right. So this little divot, this little divot is the osteocyte. Osteocyte. Or I'm sorry, this little divot is the lacuna. What am I doing? I have these in different colors. This is stupid. Let me fix that. This is the lacuna. This is the little divot or pit. This is where osteocytes. That's where they live. That's where they sit. And then this is the osteocyte. Osteocyte. Okay. Okay, and that's the kind of basic structure of the bone. So all of these cells combined with the osteoblasts and osteoclasts can result in some pretty interesting bone dynamics, and we'll talk about that in the next one. But that's all I want to talk about here with our basic bone anatomy. So with every one of these levels, we've zoomed in, or actually one, yeah, let's do that here. Let's do that here, actually. No, we'll save that for bone dynamics. We'll build it off this one. That's it for this one. This is your basic bone anatomy. All right, I'll see you in the next one.